Where to dig for dinosaurs? Session 5, The Hunt for Fossils. In 2019, an international team of paleontologists began Mission Jurassic, a month-long dig in northern Wyoming. The scientists were digging for fossils from dinosaurs that lived 150 million years ago. The dig was a huge success. The team uncovered a fossilized Brachiosaurus as well as the bones of a 30-meter-long Diplodocus. Over 600 bones were found at the site, but the digging didn't end after Mission Jurassic was complete. In fact, some paleontologists will end their careers working in Wyoming without ever having to look for another site. Hotspots. From Texas to Montana, the western United States has many dinosaur hotspots, and scientists commonly excavate complete dinosaur skeletons from the ground. Two examples include the Hell Creek Formation, a layer of rock that stretches across parts of Montana and the Dakotas, and the Morrison Formation, which extends from Montana to New Mexico. You can find Stegosaurus and Brontosaurus fossils in the Morrison Formation. This hotspot has been the most fertile source of dinosaur fossils in North America. But what makes these spots the perfect place to dig for dinosaurs? The answer is in the type of rock that is common to these places. Sedimentary rock from the Mesozoic era, 230 to 65 million years ago. Sedimentary rock is made up of mud or sand that, over millions of years, was crushed to form layers of rock. Dinosaur bones buried in this mud are turned into rock too. But finding dinosaur fossils isn't as simple as just locating an area with a lot of sedimentary rock. Fossilized remains of land animals, including dinosaurs, are unlikely to be found in rocks made from ocean sediments. Dinosaurs, of course, lived on land. Not only do you need somewhere with the right rock, but you also need an accessible surface. Lots of dinosaur hotspots are in deserts because the fossils tend to be more exposed. The Gobi Desert in Mongolia is one example. That's where many Cretaceous dinosaurs like the Velociraptor have been found. Locating dinosaurs in rock. To find out where different rock types are located, scientists use geologic maps. Unlike topographical maps, which show rivers, towns, and hills, geologic maps show us features like rock types, fault lines, and minerals. In 1815, an English geologist called William Smith completed the first complete geologic map of an entire country, England. Smith figured out that sedimentary rock layers could be identified by the fossils in them. He then used this to predict where rock types and fossils could be found. Still want to know more about how to dig for dinosaurs? Let's learn from an expert, Dr. Elena Cuesta Fidalgo, a paleontologist who's gone on digs around the world. Dr. Elena Cuesta Fidalgo works on the Paleontological Museum in Munich. She discovered her love for dinosaurs when she was just 5 years old. After completing a degree in geology at the Autonomous University of Madrid, specializing in paleontology, she went on her first big dinosaur dig in 2009 in Hell Creek, Montana. She also spent a year studying turtle fossils in Japan. Here she tells us about her fossil finds and how to know where to dig for dinosaurs. Why did you want to be a paleontologist? As a really young child, I always loved dinosaurs. I was completely obsessed with them. Then, when I was about 5, I went to see the first Jurassic Park. I remember realizing that there was actually a job that allowed you to think about dinosaurs all the time. So, Growing up to be a paleontologist became my dream. What's the most exciting thing you have found? The most exciting thing wasn't rare, but it was one of the first fossils I found when I went on a dig in Hell Creek in 2009. It was some Triceratops teeth. Dinosaurs' teeth were replaced many times over the course of their lives, so they aren't rare, and you mostly find the teeth whole. Fossils are often found in fragments, so for me to find these was really exciting. Before I went to Hell Creek, I had only been on digs for mammal fossils in Spain. So my first real dinosaur dig was amazing. As well as the teeth, I also found several T-Rex bones. My specialty is in theropod dinosaurs, which are carnivorous, bipedal dinosaurs like T-Rex. How are digs organized? The way a dig is set up is like a game of strategy. We mark out the area in little squares. For example, we might find a bone in square A6, and by doing this for each square, we can start to tell if we are looking at one complete dinosaur or different parts of many dinosaurs. Our digs are faster than archaeological digs. For example, one looking for Roman remains, archaeologists have to be slower and more careful than us, since what they are looking for is so small, but dinosaur bones are big. The first day of the dig is long and hard. This is because we have to remove the upper layer of sediment to get to the rock underneath, where we will find the fossils in sedimentary rock. How do you know where to look for fossils in the first place? We have geologic maps. We often know where to start looking because we already know about dinosaur hotspots. A geologic study tells us what environment produced the sedimentary rock, and we look for continental sedimentary rock. Sometimes finding dinosaur fossils is just luck, and we rely on people like farmers and hikers to let us know when they find something strange. The fossil could be obvious because erosion will have left it sticking out of a rock, or it could be that someone thinks they have come across something, so they call a museum. We can then go there to the area where the find occurred and investigate it. What is the ultimate question paleontologists are trying to answer? When we say paleontologist, we have to remember that there are so many different specialists within the field. My specialty is the concavinator dinosaur, a type of theropod, so my research only looks at those. I would say that the one thing we are all looking for is connections. We all want to understand how things evolved and how they are related to one another. There are so many hypotheses about the evolutionary history of dinosaurs, and I'm working to help add my little piece of information to the puzzle.